Assalamu alaikum dear students. This is our next problem. Problem once again having been chosen from the same book, Modern Physics by Kenneth S. Crane. Okay, as usual we first come to its statement. Okay, a particle in an infinite well is in the ground state with an energy of 1.26 electron volt. Ground state meaning E1. Okay, a particle in an infinite well is in the ground state with an energy of 1.26 electron volt. How much energy must be added to the particle to reach the second excited state, that is n equal to 3, the third excited state, that is n equal to 4. Dear students, simple problem, just depending on one tool which defines energy levels in a energy levels of a particle in a box. Okay, so actually we will find E1 is given, then we will find E2, E3 and E4, then we will subtract E3 minus E1, E2 minus E1, E3 minus E1. Okay, tool, only one tool is applied in this problem. Okay, tool number one and the only tool. Okay, energy levels for a particle in a box, En equal to Pn square over 2m, where Pn is the magnitude of momentum and m is particle's mass. This alternatively becomes equal to n square h square over 8m capital L square, where capital L is width of box and h is Planck's constant. This alternatively becomes equal to n square pi square h cut square over 2m capital L square. Dear students, here 8 has been replaced by 2 because h cut means h over 2 pi. When we will put h over 2 pi in place of h cut, then we will revert to previous step. Okay, where n is quantum number, n equal to 1, 2, 3. Okay, we know that En equal to n square h square over 8m capital L square. Okay, tool, only tool number 1, which describes energy levels of a particle in a box. Okay, it is given that E1 equal to h square over 8m capital L square equal to 1.26 electron volt. Okay, E1 is given, ground state referring to E1. This implies that E2, dear students, E2 will also be same as E1 except the difference will be that in place of n equal to 1, here n will be equal to 2 and hence 2 square will become equal to 4. Okay, so E2 will be equal to 2 square into E1 equal to 4 into value of E1 which is given in the statement 1.26 electron volt, and this becomes equal to 5.04 electron volt. Similarly, E3 becomes equal to, and now we will put n equal to 3 and 3 square is 9. So E3 will become equal to 9 into E1. Okay, 9 into 1.26 electron volt, and this becomes equal to 11.36 electron volt. Now E4 will become equal to 4 square into E1 because we will put n equal to 4 and 4 square is 16. So E4 will become equal to 16 E1, that is 16 multiplied by value of E1, that is 1.26 electron volt, and hence E4 becomes equal to 20.16 electron volt. Now delta E2 means E2 minus E1. Dear students, here every delta will correspond to ground state, that is E1. For example, delta E4 is equal to E4 minus E1, that is okay. Delta E4 is not equal to E4 minus E3. Similarly, delta E3 is also equal to E3 minus E1 ground state. Delta 3 is not equal to E3 minus E2. Okay. So now delta E2 is equal to E2 minus E1 equal to 5.04 electron volt minus 1.26 electron volt, and this becomes equal to 3.78 electron volt. Now delta E3 is equal to E3 minus E1. Okay, in every delta E we will have reference with E1 ground state. Okay, so E3 minus E1 becomes equal to 11.34 electron volt minus 1.26 electron volt, and this becomes equal to 10.08 electron volt. Similarly, delta E4 is equal to E4 minus E1 is equal to 20.16 electron volt minus 1.26 electron volt, and hence delta E4 becomes equal to 18.9 electron volt. Okay, and this is the end of our problem, and this is the end of our video. Till next video, Allah Hafiz.